Hi, it's Gene from mavestar Observatory. Guys, I'm really going to enjoy doing this video, and just briefly before we get into it, I just want to thank those people that have decided to overstep the mark and step forward and support what we do. So I'm really looking forward anyhow to this video, because at the end of it, I think a lot of people are going to know exactly what their situation is, and it really depends on the latitude of where you live on this earth as to how it is going to affect you. Now, we do seem to be in a period of time where, since at least 2007, we are starting to see temperatures drop. But for the last 33 years, we've seen 3 solar cycles also diminish, and it doesn't look like at this point in time we're going to see the start to solar cycle 25. Now, that might not be the case, but just going on the previous trend of what we've seen already, it sure does look like that is going to be the case. But does sunspot activity regulate the temperatures on Earth? Now, if we start by looking at the 400-year sunspot observations, we can see that they have classified the during the Maunder minimum period, which they classified as the Little Ice Age, of a period of time from 1650 to 1700s. But on the left-hand chart, you can see that the Little Ice Age extended a lot longer in time than that, almost 400 years. Starts at 1400, ends around 1800 or just after 1800. And you might ask yourself the question, why did they call it a Little Ice Age? Could it be that, as we can see on the left hand side of this column, that when temperatures go below zero, something very strange happens to liquid water? It freezes into ice. So that might be a clue as to what defines an ice age as opposed to a non-ice age. So clearly, depending on your longitude of where you are on this planet, is dependent on whether you are in an ice age or not. If you're living in the Antarctic region or the Arctic region over the northern hemisphere, you could argue that you are still in a glacial period, because there are glaciers there. Now, the last glacial period extended south all the way to mid England and all that across that latitude, across Europe and the United States. So most of the northern hemisphere was covered by not just ice but also glaciers, and that's what defined it as a glacial period. So if you're living in a period of time right now at a certain latitude, like in Canada, where every day you experience temperatures below 0 degrees Celsius, you could say, if this had gone on for 5-10 years, that you were in an ice age. But here in the United Kingdom, at central England, there is no ice age. So we're not experiencing temperatures at 0 degrees for many years, and it's a good thing, because if we look at the left-hand chart, we can see when the Vikings arrived in Greenland and colonized it, and it was only after probably 150 years temperature started to dip below 0 degrees. But they'd already been there a good 100 years or so, and at that point in time agriculture would have been possible, even though temperatures are just marginally above freezing. That's the difference between ground being frozen solid and not. That's the difference between able to grow crops of certain kinds and not. And as we can see, they did, for a period of time of about 50 years, settle there, even though the temperatures had dropped to -0. And then they rose again to about 0.4 degrees for another period of about 70 years, and then they dropped again. And at the bottom of that peak where they dropped, around about this location here, where we see the end of the Viking civilization colonization of Greenland, they give up, because simply they weren't going to be subject to many years of what could possibly be the same outcome with regards to climate. And as you can see, it did warm up slightly after they left, but then plummeted into what was known as the Little Ice Age. So, to answer the question, does sunspot numbers drive climate? Well, we can see that 400 years ago, the Little Ice Age began. That was when temperatures started to dip into sub-zero temperatures. And if we look on the right-hand chart, we can see that the Little Ice Age is still described from 400 years ago to 1800 years ago. But on the right-hand chart, where the 400 sunspot observations begin, you can see it is 1600 years. If we go back to the first chart, we can see where 1600 years is, slap bang in the middle of an already occurring ice age. But here's the thing, I've marked here in purple a line, and that represents from 1600 to 1650 or thereabouts. And what we can see below is, on average, or just starting to decay into the Little Ice Age sunspot numbers. But even at 1625, we still have sunspot numbers on and around about 40. So it's clear sunspots didn't regulate the temperature, because the sunspots were dropping off in the 1650s to zero. And yes, that is a point in time where is noted as being the Little Ice Age, but it wasn't because sunspots had already dropped, because sunspots were still there in the 1600s, quite clearly seen on the 400 year of sunspots observations. So what this tells us is that temperatures had dropped well before sunspot numbers hit zero, and for that reason we can't say that sunspots regulate temperature. It's as clear as day, and there is no argument, because the facts are in front of us. So, like I said, we do seem to be experiencing slightly cooler temperatures on this planet, and we are starting to see some agricultural lines go offline because they are no longer able to, maintain those crops that would have thrived in slightly warmer temperatures. But that doesn't mean that we're in a Little Ice Age. Or should I say, that all depends on what longitude you're at on this planet. You see, it will affect people that are further north, and they might consider themselves, if they're living in a period of time where temperatures are constantly below zero, to be in an ice age. It would be acceptable for that, especially if there wasn't a day in the year that went over that temperature. So I hope I've cleared up this point. And if you're not going to start, if you're one of these other channels and you don't accept the fact that 1600s we still got sunspots, yet we are still experiencing the Little Ice Age, then it's very difficult, for all the other people out there that are listening to you right now talk about the sunspots driving climate, because all we're going to do is confuse them even more. Because for the last 20 odd years, we've had people like Al Gore coming out blaming CO2 for carbon dioxide for global warming. But that isn't even the case. We can see that temperatures were rising from 1750 or 1760, which was the Industrial Revolution. We could see temperatures had already started to rise. It wasn't because of the Industrial Revolution that temperatures began to rise. It was something else. It was something else that caused, the Little Ice Age 400 years ago. And we need to find out what that was. What is regulating the temperature on this planet, and how can we forecast, once we understand what it is that's regulating the temperature on this planet? It's going to be very difficult. If I just slightly deviate, guys, what we need to do, more importantly, I think, is focus on cosmic radiation. We're going to have a look at that chart again I showed you in yesterday's video. But obviously, our observatory does not have the funds and would never be able to raise the funds to investigate cosmic radiation in past history, because to do that we'd need to take a core sample of somewhere in a lake, probably, that had been around for the last million years, perhaps the Black Sea, I don't know, or somewhere like that, you know, where it's landlocked and it's a large freshwater reservoir. We'd need to take a core sample of the sediment at the bottom, and it'd have to be a very deep one because we'd have to go back 780,000 years in that core sample to find out what pollen was in there and the amounts of pollen. And the reason why we'd be checking pollen samples and amounts is that would give us a good indication of what the temperature was like first of all back then. I'm sure there's a Vostok core sample that does account for temperature. I'm not sure how well it does for cosmic radiation, but what we would have to look for is beryllium, which would be a byproduct of cosmic rays, in that sample. And we could then go back to the last magnetic reversal and just see just how much quantity of cosmic radiation was inbound during that reversal period. So we'd be focusing on a very small band in the core sample over that period of time where the poles actually reversed and the magnetosphere dropped, and as a result there was a lot more cosmic radiation inbound. I'm not convinced that it would be coincidentally the same as what we're experiencing right now, because I think to have a pole shift and a continuous decline in sunspot activity, which or solar activity, let's put it that way, because we know directly what that causes. When the sunspot goes through weakened periods of time, we have extended amounts of cosmic radiation in. Let's go and have a look at that chart so it's better understood, and let's have a look at the 2014 environment space overview, because that covers a little bit more of the solar cycle 24, where we see the peak of solar cycle 24, and we also see the heliosphere failing as a result of that weakened solar cycle. Okay, so what I wanted to show you is these two solar cycles and point out just what has changed during the last solar cycle, which is solar cycle 24. So we're looking at solar cycle 23 here, and we can see that in a solar maximum, when the sun's at its maximum output, we can see on the cosmic ray levels that they're dipping below the line, which means, you know, that we've got a healthy or a healthy-ish amount of sun activity, which is pushing, you know, the heliosphere or inflating the heliosphere enough to keep out, at least during this period of time, solar maximum cosmic radiation, or keep the levels actually lower than what they should be. But what we see for the very first time around about 2014 would have been solar maximum of solar cycle 24. We see that the levels are still continuously, even though they're not as high during solar minimum, but they are still creeping in, which means our heliosphere is no longer strong enough during solar maximum to push away the cosmic radiation. So not only are we getting large amounts during solar minimum, which is what we're at right now, and this chart doesn't show us the end of solar cycle 24, because if it did, this amount of solar radiation that we experienced at the end of solar cycle 23 during solar minimum period had almost increased fourfold. I would expect to see at the end of solar cycle 24 an increase by eightfold or even more. But the most important point here is, guys, is that our first line of defense against cosmic radiation is starting to fail. And I'm telling you now, when the organisations first saw this, that would have been the fuse lit to then pump literally trillions of pounds into the investigation of cosmic rays, and so they could get an idea of what they're facing as a result of this, because they are in the same knowledge as everybody else, unsure as to how long this is going to continue, and to ensure, you know, at least if it is you know, threatening human continuity on this planet or biodiversity across all the ranges, you know, they are, you know, probably even planning, you know, to extend the continuity into the future. So it is a very serious topic. It is a big story that has not even hit a single time the headlines right now. You've got this information, guys, and you're probably only 1 or 2% of the knowledge of this information, and I'm glad I covered, you know, what defines an ice age and what defines a glacial period of time, because our records show that we are entering another glacial period, and what we could be experiencing now with temperatures creeping gradually lower and lower, changing seasons which farmers rely on to grow the crops for the world production of food for the masses, the 7 billion of us, could be the starts of another glacial period. You know, I follow trends, and you know, with trends, if they don't change, you can make a prediction that it's going to continue until you see some sort of middle point where things start to get a little bit better. And you've only got to wait a bit of time when they start to get better to get an idea or an angle of how better is it. I'm just saying right now, our first line of defense, our heliosphere, which protects our solar system from cosmic radiation, has begun to fail. And as a result, more cosmic radiation is inbound. Now, in 4 to 7 years' time, guys, our magnetosphere is going to go to very low levels during that magnetic reversal. And during that point in time, we are going to experience the full force of this cosmic rays inbound in our atmosphere. It will start to strip away some of the upper atmosphere at some points if the levels continue to grow at the rates they possibly are already. We're going to experience what's a term known as sputtering. This is exactly what happened to Mars. It doesn't mean that things won't change in the distant future to prevent this happening, but I'm just saying, you know, this cannot be said either way. It can't be argued either way, because simply we don't know how long this period of time is going to last. But what worries me is that we are 500,000 years overdue a magnetic reversal. And does that mean that during the reversal period of time, that is also going to be extended? Because if that is the case, it's not going to be very good, for the fact that we know already what cosmic radiation can do to biodiversity, let alone ourselves. You know, it can interfere with the DNA, causing carcinogenics of any cell which it interferes with. It could be liver cells. We've got that many cells in our bodies. Cosmic radiation can affect one of those cells at any given point in time, and as a result can cause damage to the deoxynuclear acid, or the DNA, and as a result of that you have a mutation. And when you get mutations, you know, the cells no longer abide by the planned structured rules of reproduction. They grow into lumps, cancers, and etc. as a result. So, you know, it is fundamentally important that we put those pieces of equipment out in January to those, first of all, weak regions of the magnetic intensity and the strong regions of magnetic intensity. You know, those are the things we can manage, and with the budget that we get at this observatory, you know, we haven't got the funds. We're probably talking millions if you want to go start doing core samples, looking at beryllium during periods of time when magnetic reversals are down, so we can get an idea of how long things last during a regular magnetic reversal. But this is by all means an irregular one, because before 780,000 years ago, when there was a last magnetic reversal on this planet, on average we used to go through one every 300,000 years. And that is of course excluding the magnetic excursions that have happened from 780,000 years to the present day. And an excursion is a failed reversal. That's when the poles do deviate from their locations, or their fixed locations, but maybe they don't go into the weak field lines and they go back to their original location. That's called an excursion or a failed reversal, whichever you prefer. So, you know, guys, I hope I've cleared up a couple of things. First of all, about sunspots with relationship to temperature, and our history of temperature, and our history going back 400 years of sunspots. And I hope, you know, you understand now that we are in completely new territory. This is undocumented, where, you know, even that during a time period of solar maximum, solar cycle 24, you know, cosmic radiation was still coming in plentiful at that period of time. Okay, I think it's enough for today, guys. I'll catch up with you. I'm hoping that either today or tomorrow, we get this new sensor, because I want to show you that it's a really good thing to add to what we do already here. That's monitoring the oxygen levels of the atmosphere, and it's going to be able to be doing that at any given time we want. We could set it at 5-minute intervals, 15-minute intervals, whichever we choose. We've got that option, but I'm just waiting for that to come, and I can show it you. Okay, guys. Hopefully you've got a better understanding of this big breaking news. It is solely related to the amount of cosmic radiation. It is related to the last solar cycle we experienced, solar cycle 24. During the maximum, more cosmic radiation was inbound, as opposed to all the other cycles during maximum where it pushes it away. So I'll leave it with you there. Just mention briefly, there is a link down there if you want to support what we do at the observatory. We're not just talkers, we actually build equipment, and for that reason we are an observatory, because we monitor regularly at 3-second intervals the position of the magnetic North Pole. So there's a link down there if you want to support us. I'll catch up with you in the week some point. Take it easy. Have a good day. Bye for now.